Welcome you all to session 4 of the chapter Motion in a Straight Line. In this session, we will be studying about relative velocity and solve some problems related to motion in a straight line. Okay, let us begin with the first concept, that is relative velocity. If a body is moving, we speak about its velocity. But when we speak velocity of a body with respect to another body, this concept comes into existence, that is relative velocity. For instance, if you are sitting in a train and the neighboring train begins to move, what do you feel? You feel that your train also begins to move in the opposite direction. But after some times, when the neighboring train passes away now here, that time you come to know that your train was rests, but you felt that the train was moving in the opposite direction of the neighboring train. So that velocity is called as relative velocity. What is relative velocity? Let us check it out. Velocity of a body with respect to another body is called relative velocity. Whenever we speak about relative, we have two bodies, right? Velocity of a body with respect to another body is called relative velocity. Okay, let us understand about this relative velocity much more, taking an example now here. Consider two bodies. Consider two bodies A and B moving with velocities VA and VB respectively. Okay, let me consider two bodies A and B. A's velocity is VA and B's velocity is VB. Okay, there are two cases now here. First case, A and B are moving in same direction. What happens if you consider A and B are moving in same direction? Okay, let me consider there is a particle A now here. This is a particle A which is moving with velocity VA in this direction, and let me consider another one particle B and it is moving with velocity VB. Right, now let us check it out. What is the relative velocity? That is relative velocity of A with respect to B. Okay, I am speaking about relative velocity of A with respect to B. It is denoted by VAB. What is the meaning of VAB? Relative velocity of A with respect to B. That is VAB. Okay, let me find what is relative velocity of B with respect to A. It is noted by VBA. Right, relative velocity of B with respect to A, relative velocity of A with respect to B. It is given by, see here, if two bodies are moving in the same direction, then what is the velocity of A with respect to B? It is VA minus VB. This is VB minus VM. Right, we need to subtract the velocities if the A and B are moving in same direction. So what is the relative velocity of A with respect to B? VAB is equal to VA minus VB. Right, relative velocity of B with respect to A, VBA, that is VB minus VA. This is the case when two bodies are moving in same direction. Okay, let us understand what happens if two bodies are moving in opposite direction. Let us take that example now here. When two bodies are moving in opposite direction, how to consider the relative velocity, and we will be studying comparatively. Let me take second one, that is A and B are moving in opposite direction. What happens? Let us check it out. Opposite directions, same directions and opposite directions, right? Okay, for example, this is a particle A which is moving in this direction. Let me take it as VA. And let me take, this is a particle B which is moving in opposite direction, that is VB. This is VA and this is VB. Now let us consider what is relative velocity. So we are speaking relative velocity of A with respect to B. It is noted by VAB, right? Okay, now let me speak about another one, relative velocity. We are speaking now relative velocity with respect to B with respect to A. It is noted by VBA. If they are moving in opposite direction, the relative velocity is VA plus VB. This is VB plus VA. It is nothing but VA plus VB, right? Do remember, if they are moving in opposite direction, relative velocity is the addition of the two velocities. If the particles are moving in the same direction, it is the subtraction of the two velocities, right? This you have observed in day-to-day life. Whenever you are traveling, right, your car is moving in this direction, but if you see there is another vehicle which is moving in the opposite direction, right, you feel that the vehicle which is coming in the opposite direction is having more velocity than you, right? So it is having more speed than your car now here, right? For example, if you are traveling with 60 km per hour and the opposite vehicle is coming with 40 km per hour, you feel that the opposite car is about 100 km per hour. Means you are adding the velocities, right? Usually we feel that, right? So whenever we are traveling, the vehicle which is coming in the opposite direction, you feel that they are moving with a faster velocity, zoom, zoom, like they are moving with a faster velocity. Why do you feel? Because they are moving in the opposite direction. But if there is another one vehicle who is overtaking you now here, you feel that, okay, it is having velocity just more than you, not that much of speed you feel, right? But the vehicles which are coming in the opposite direction, you feel the vehicles are moving with more velocity. That itself is called as relative velocity. That is why we are taking like this. Do you remember, if two vehicles are moving in the same velocity, same direction, we take subtraction of the velocities. If they are moving in the opposite direction, we take addition of the two velocities, right? For instance, let me check it out. If your vehicle is moving with 40 kilometers per hour, right, if another one vehicle is moving with 60 km per hour, you feel that the other vehicle is moving with 60 minus 40, 20 km per hour. Here you will be subtracting, here you will be adding. So this concept is called as relative velocity. Whenever you consider velocity of one body with respect to another body, then that velocity is called as relative velocity, right? Do remember this. So this was all about motion in a straight line. Now let us solve some problems on this chapter now. First problem is like this. A body is starting from rest and is subjected to a uniform acceleration, means the body is moving with uniform acceleration of 10 meter per second square. Determine three quantities. One, velocity at the end of 5 seconds, displacement in first 3 seconds, velocity after the displacement of 20 meter. Okay, let me analyze the concept now here. First of all, whenever you solve with the problem, first write what is given. Right. So first of all, a body is starting from rest. This line will tell you something. Means a body is starting from rest. Means what is the initial velocity? 0. Do understand? Whenever a body starts from rest, means what was its initial velocity? That is 0. Right. If in the question, if you see that it is starting from rest, it indicates that initial velocity is 0. Okay, let us check it out now here. That is initial velocity. So initial velocity is given. How much is initial velocity given? 0. Right? And starting from rest is subjected to uniform acceleration. Means it has some acceleration. That is uniform acceleration. So what is the acceleration it has now here? 10 meter per second square. That is the acceleration. Means the body starts from rest and moves with the uniform acceleration. Do remember, whenever a body is moving with uniform acceleration, you can use kinematic equations. Right? We have three kinematic equations. V is equal to U plus AT, S equal to UT plus half AT square, V square is equal to U square plus 2AS. So you can use any of the formula which is suitable to use in the problem. We can use that now here, right? Okay, let me begin to solve the problem. First one, this is the given, and let me go with the first one, that is A. So what is asked? You need to find the velocity of the vehicle at the end of 5 seconds. You need to check it out. When the body begins to move here, right? So what is its velocity at the end of what we say here? 5 seconds. Means what is this? What is given 5 seconds? It is nothing but time, right? Time is given, t is equal to 5 seconds. What do you need here? Velocity. Velocity at the end of 5 seconds. Means you need to find a velocity at the end of 5 seconds. Means you have u A, you have T, then which is a suitable formula? V is equal to U plus AT, right? Because you want a final velocity, right? So let me using equation V is equal to U plus AT. This is suitable because you have U, A, you have especially T now here, right? So we can use this formula. V is equal to U plus AT. Come on, what is initial velocity? Initial velocity is 0, right? Plus, what is the acceleration? 10. What is the time? That is 5 seconds. Right? How much do you get here? 0 plus 50, it is nothing but 50. What is its SI units? Just check it out. It is the final velocity. Means what is the SI unit of velocity? That is meter per second. Writing unit itself carries 1 mark. Do remember, right? So whenever you calculate the physical quantities, you need to mention its SI unit. So what is the velocity at the end of 5 seconds? It is 50 meter per second. Do you remember? This is the final velocity. And we have solved this by using the formula V is equal to U plus AT. Just think it out which formula is suitable. Just apply it and you can solve it. Just we have completed first one. Let us move to the second one. We need to calculate displacement of the body in first 3 seconds. Means after 3 seconds, how much distance the body traveled, right? Okay, let me go with the second one. That is displacement. Let me consider displacement in first 3 seconds. Let me go with the second one. That is displacement in first 3 seconds. In first 3 seconds. Means again, what is given? Time is given. That is how much now here? T seconds. What is required? Displacement. S is required. So which formula shall I use? Right? As you require displacement, you cannot use V is equal to U plus AT because it does not have any displacement. But you have the formula for displacement. Right? So what is the formula? S equal to UT plus a half AT square. Shall I use this? Yes, because you know U, you know T, and you know A also, right? So what is this? Initial velocity. What is this now here? It is 0, right? 0 into something is also 0 now here, right? So directly you can mention 0 now here, or you can write like this, half. What is the AMN? Acceleration. That is 10, right? What is the T? T is 3 seconds. T3 square. Okay, this will become 0 plus, how much do you get? Into 10 into 9. Right? Okay. So it cancels. 9 5s are 45. And just figure out what is the unit of displacement. Displacement is a distance. Means what is its unit? Unit is meter. So how much did the body travel in first 3 seconds? That is 45 meter. So I used the kinematic equation S equal to UT plus half AT square. This is how we need to choose now, right? So we have completed second one. Let us move to third one. Velocity of the body after the displacement of 20 meters. So how to do this? Let us check it out. Let us solve the third section of this problem now here, right? Okay. Let me go with third one. That is, you need to calculate velocity of the body after displacement of how much now here? 20 meters. Means what is given here? Displacement. Means you know what is given here? Displacement is given. Means S equal to how much? 20 meters. So what we need to calculate? V. You need to calculate V. U. A is given. You need to calculate V when S is given. V equal to U plus AT? No, you cannot use that because time is not given here. S equal to UT plus half AT square? No, there also T exists now. That's why we cannot use that also. Means left out is V square is equal to U square plus 2AS. Yes, we can use that because it does not have any term called a T there. So let me use that because other terms you know here, right? So using V square is equal to U square plus 2AS. Okay, let me substitute V. That is what we are calculating. U, that is 0 plus 2. Acceleration is 10. What is the displacement? It is 20, right? If you calculate this, you will be getting with 400, right? Okay, then if you want to calculate V, that is square root of 400, that is what now here? 20 meters. Sorry, meter per second, because it is what now here? Velocity. SI unit of velocity is meter per second. Means After the displacement of 20 meter, what is the velocity of the body? The velocity of the body is 20 meter per second. This is how we need to solve. So we have solved the third case also. That is how. So first write what is given, then you just figure out which kinematic equation is suitable to use there, right? And then we can solve the problem. So this was the first problem. Let me move on to the second problem. Second problem. A car moving along a straight highway with a speed of 35 meter per second is brought to rest within a distance of 200 meter. Means now the car is already moving. In the first problem we have seen that the car was at rest. Now the car is not at rest. It is already moving now here, right? The car is moving along a straight highway, and it is also moving along a straight highway with a speed of 35 meter per second. First let me write what is given. The car is already moving, means it has some initial velocity. What is the initial velocity? 35 meter per second. So what is initial velocity? Initial velocity u, that is how much now here? 35 meter per second. A car is moving in a straight highway with a speed of 35 meter per second. If a car is moving in a straight line, that time speed can be considered as velocity. Do remember, right? We have studied about this. If a body is moving along a straight line, its speed is nothing but its velocity, right? So that is why initial velocity u is equal to 35 meter per second is brought to stop. Means it is brought to stop. Means what is the meaning of this? Means what is the final velocity? 0, right? Okay, let me write. What is the final velocity? The final velocity is 0. Do you understand? If a body begins from rest, then the initial velocity is 0. If the body stops, is brought to stop, then the final velocity is 0, right? This is the second problem in which the car was already moving, it is brought to rest, means final velocity is 0. Within a distance of 200 meter, means what is this? This is nothing but what? Displacement. Since it is moving in a straight line, the distance can be considered as displacement. So how much now here? It is 200 meter, right? So what is asked? What is its retardation? What is the retardation, right? So we need to calculate retardation, and how long does the car takes to stop, that we need to calculate. First let me calculate retardation. So you need to calculate retardation. I already told you that retardation is nothing but negative acceleration. Means what you need to calculate? Acceleration. Do remember, retardation is a word which is called as negative acceleration. Means if you increase the acceleration, we call it as simply acceleration. If you decrease the velocity, that acceleration is called as retardation. Do remember, the question is asked, calculate retardation. Means what you need to calculate? You need to calculate acceleration, and definitely that will come in negative. That is why the name retardation. So you need to calculate retardation, negative acceleration. Okay, now let us check it out which formula is suitable here, right? We have u, v, s and a using. Okay, let us check it out. Can I use v equal to u plus at? No, I cannot use, because time we don't know. S equal to ut, again time is there, time is not given. I cannot use second formula also. So let me move on to the third formula. What is that now here? V square is equal to u square plus 2as. Shall I use this? Right? Okay, what is this? V square. Final velocity 0. What is initial velocity? 35. Let me take 35 square, right? Plus 2 into acceleration. Yes, that we need to calculate. What is this? Yes, now here. Yes is 200. Let me take it is 200. So let us check it out. What is 35 square? 35 square. How much is 35 square? 1225. 1225. 1225 plus what do you get now here? 400a. Right? Okay. If you bring this 400a this side, minus 400a is equal to 1225. A is equal to minus 1225 divided by 400. So minus. So how much do you get? 1225 divided by 400. So if you calculate this, you will be getting this 3.06. 3.06. 3.06. What is the unit? Acceleration. What is the unit of that down here? That is meter per second square. Do remember, this is minus 3.06 meter per second square. So this is minus, that is why that acceleration is called as negative acceleration. This is what we got now, right? Now let us move on to the second one. This is first, we already calculated retardation. It comes to be minus 3.06 meter per second square. Next, we need to calculate how long does it take the car to stop. Means what is the time taken to stop the car. Let us calculate the second part now here. Time taken to stop the car now here. Let me calculate what is the time taken to stop the car. To stop the car means what you are calculating, what you need to calculate, T, right? Okay, now which formula shall I use? Using which formula? Shall I use first one? V is equal to U plus AT. Yes, we have all the things. Shall I use the first formula? Yes, using V is equal to U plus AT. What is final velocity? It is 0. What is initial velocity? It is 35. Acceleration, we calculated it now here. It is minus 3.06. Right? So this is acceleration into what we say now here, time. That we need to calculate it. Right? Since it is negative, when it comes this side, it will become positive 35. T is equal to 35 divided by 3.06. If we calculate this, 35 divided by 3.06, it comes to be 11.44. It comes to be 11.44, and SI unit of time is second. Means after 11.44 seconds, car stops. Right? So this is the time taken by the car to stop after the retardation, right? After negative acceleration of minus 3.06 meter per second square. So this is how we need to solve the problem. If the question is asked like this, the moving car stops, a moving body stops. In the first problem we have seen the stopped body begins to move, right? The second problem we have seen the moving body stops. Now let us take the third problem. Third problem is like this. A car starts from rest and accelerates from rest uniformly for 10 seconds to velocity of 36 km per hour. Okay, the car is at rest, it begins to move here, right? It begins to move for 10 seconds to the velocity of 36 km per hour. Means a car starts from rest, means what is initial velocity? 0. It begins to move here, right? It begins to move means you are giving acceleration, right? And it reaches up to 36 km per hour. Then what happens? It then runs at a constant velocity and is finally brought to rest in 50 meters, right? When it is moving and after it is deaccelerate, right? Retardation. So it comes to rest after moving for a 50 meter, right? When retardation is given and finally brought to rest in 50 meter with uniform retardation, find acceleration and retardation. Okay, this is the third case, right? In the first case, we have seen the car was at rest and it begins to move. Second case, the car was moving, it comes to rest. In the third case, the car was at rest, it begins to move and then comes to rest. In the first case, only acceleration was there. In the second case, we speak about retardation here. In the third case, we have both because it begins to move and comes to rest. We have acceleration as well as retardation and we need to calculate the both. Right? First, let us calculate acceleration. Okay, let me start with the first case. Right? In the first stage of the car on a bike here, it accelerates and afterwards it retards. Okay, a car starts from rest. Okay, let me calculate first one. To find acceleration, let me go with the retardation later. To find acceleration, okay, first half, let us take a car starts from rest means what is the initial velocity? What is initial velocity? 0, right? Car starts from rest and accelerates from rest uniformly for 10 seconds. Means what is 10 seconds? Time, that is equal to 10 seconds to a velocity of 36 km per hour. Means what is this now here? Final velocity, right? It moves with the velocity, that is final velocity. How much is final velocity? 36 km per hour. And one thing you need to note down here is final velocity is given in terms of kilometer per hour, but it is not the SI unit. Whenever you take the quantities, you must take in SI unit. If it is not given in SI unit, convert into SI units. Okay, now I will be converting kilometer per hour in meter per second. How do I do that? Let us check it out. Right? 36. How much meter is 1 kilometer? 1000. I can write like this. Kilometer. I will be multiplying it by 1000 so that kilometer is converted into meter. 1 kilometer is equal to what we say 1000 meters. So per, right? Hour should be converted into seconds, right? So 1 hour, how many minutes it has? 60 minutes. In 1 minute, how many seconds do you have now here? 60. So if you multiply it by 1000 divided by 60 into 60, then this kilometer per hour is converted into what we say here? Meter per second. This is how we need to convert, right? Kilometer per hour to meter per second. Now let us check it out. 0 will get cancelled. This 36 will get cancelled. It will be remaining with 10 meter per second. Means 36 kilometer per hour is nothing but 10 meter per second, right? This is how we need to convert from kilometer per hour to meter per second. Do remember, whenever you write a physical quantity, you should write in SI unit. If it is not, convert into SI units, right? Okay, then this is the case, and you need to find acceleration. How do you find? You need to find acceleration, that is A. Okay, come on, tell me, which formula shall I use? I'll be calculating the first part of the problem, right? Let me take the first part of the problem, right? I consider only the first part. Come on, tell me, which formula shall I use? A, V, T, U, right? Shall I use first kinematic equation? V is equal to U plus AT? Yes. Time is given, so you can use what now here? V is equal to U plus AT. V is equal to U plus AT, right? Okay. Now, what is V? Final velocity 10, right? What is initial velocity? It is 0. Plus what is acceleration? That you need to calculate. What is the time here? 10. Shall I write like this? So what do you get now here? That is 10 is equal to 10A. Means you need to calculate A now here. A is equal to 10 divided by 10. So A is equal to 1. What is the unit? Meter per second square. Do you remember? Right. So what is the unit of acceleration? Meter per second square. So how much it is now here? 1 meter per second square. Right. This is acceleration. Right. Here the car was at rest and it begins to move. The first case I have considered. Now let me go with the second part. The moving car stops now here. Let me take that and calculate what is the retardation. Right. Okay. Now second one, to calculate, this is how we calculated acceleration. Let us calculate retardation. So how do you calculate it? Second one, to calculate retardation means, let me take the second part to calculate the retardation. This was the acceleration. Now let me go with the second part. If then runs at a constant velocity, what was the velocity? 35 km per hour. Okay, now the car is moving at 35 km per hour, it comes to rest. Means, what is the initial velocity here? Initial velocity. In the second case, in the second part of the journey, what was the initial velocity? 35 km per second. Now that becomes initial 35 km per hour. We have already converted into meter per second. How much did you get now here? 10 meter per second, right? Okay, this is the initial velocity. Okay, moving car, it stops. In the second part, car is already moving, it stops. When it stops, which velocity I need to consider? Final velocity. What is the final velocity? 0. Then, what is given? Let us check it out. If then runs at a constant velocity and is finally brought to rest, final velocity is 0 in 50 meter. Then what is this 50 meter? That is displacement, right? Displacement, that is equal to how much now here? 50 meters, right? Now you need to calculate retardation. Yes, you need to calculate retardation here, right? So we need to calculate retardation. Retardation, right? Retardation means acceleration. You need to calculate. Which formula shall I use now here? V is equal to U plus AT? No, I cannot use that because T is not there. S equal to UT, again T comes. It is not there here, so I cannot use first two kinematic equation. Let me move on to the second one. Third kinematic equation here. That is using V square is equal to U square plus 2as. Shall I use this? What is V? It is 0. Let me write 0. What is U? 10 square plus 2. What is acceleration? That we need to calculate. What is displacement? Yes, is the displacement. Displacement is 50. Right. So what do you get? That is equal to 100 plus 100a. Okay. Let me bring this 100 at this side. So we'll be getting with minus 100a, right? So what do I get now here? Minus 100a is equal to 100. So what is a is equal to minus 100 divided by 100. This will get cancelled. So what is acceleration equal to? Minus 1 meter per second square. This is retardation, right? So retardation, we got it as minus because there the car stops here, right? That is why we speak about retardation, negative acceleration, and this is how we need to calculate. So in the third problem, we have seen that the car was at rest, it begins to move, then it came to rest. In the first part, there was acceleration. In second part, there was retardation, and we calculated both acceleration as well as retardation. So this is how we need to solve the problem if the question is given like this. Now, let us move on to the last problem. Fourth problem. A ball is thrown vertically upwards with the velocity of 20 meter per second from the top of the building. Means we are seeing now vertical motion. Till now we have seen horizontal motion here. Now we are going with the vertical motion. Okay. The ball is thrown vertically upwards with a velocity of 20 meter per second from the top of the building of height 25 meter. Okay. Building height is 25 meter and you are standing at the top of the building height and you are throwing a ball with a velocity of 20 meter per second. So how high will the ball reach? The question is asked how much high the ball will reach if you throw with a velocity of 20 meter per second. Let me take it diagrammatically so that you can understand it. Okay, let me solve this problem here, right? Let me take the solution of this problem. Okay, this is the first part, that is how much height will the ball reach? Height of the ball reached. Height of the ball reach. Let us calculate how much height the ball reaches now here, right? Okay, a ball is thrown vertically upwards with a velocity of 20 meter from the top of the building of height 25 meter. Let us take a building now here. See here, this is the ground and it is the building. How much is the height now here? 25 meters is the height of the building, right? Okay, and you are standing at the top and you are throwing a ball. Okay, there is a ball and you are throwing it upwards. Right, okay, you are throwing it upwards with the velocity. So what is the velocity now here? 20 meter per second. Means what is this now here? Initial velocity. How much it is? 20 meter per second. From the top of the building, find the height. Okay, how much height the ball reaches? For instance, let us take journeys like this. It reaches and it comes down here, right? What is the height? Till here we need to calculate what is the height now here, right? Do you remember? Whenever a body is thrown like this now here, right? When it reaches at the top, its speed is 0. Do you understand? Its velocity is 0 at the tip. Do you understand? Right? If I throw this, the velocity goes like this, and at a small instant of time, the speed of this body becomes 0. Do you remember? Whenever a body is thrown, right, at the top of its motion, its velocity is always 0. Means what is the initial velocity? 20 meter per second. Now let me check it out. What is the final velocity, man? At the top now here, final velocity is 0. Let us check it out. The final velocity is 0, right? Okay, we know that the acceleration due to its gravity is downwards, right? If I leave it, it comes downwards because this body gets acceleration due to gravity. Okay, you know what is the acceleration due to gravity? Small letter g. What is its value? 9.8. But in the question it is given that you need to take it as 10. Okay, let me take it as 10, right? Okay, now acceleration due to gravity 10 means what is the acceleration of the body? Do remember, if the body is thrown upwards, right, its speed goes on decreases and at the point it will be 0 and again it increases. Do you understand this motion, right? If I throw some body, its speed goes on decreases. For example, if I am throwing with 20 meter per second, it will become 19, 18, 16, 15, 5, 4, 3, 2, 1, 0. When it becomes 0, that is the end of the motion. Then again it increases 1, 2, 3, 4 like this. So means when the body is moving upwards, its speed decreases because acceleration is towards downwards now here, right? That is why if the body is moving upwards, the acceleration, that is A, let me take now here, acceleration, let me take it as minus g. Why did I take minus? Because acceleration due to gravity is always downwards. We shall take like this. This acceleration, let me take it as g, and if body is moving upwards, let me take it as minus g because it is moving opposite to this motion here, right? The acceleration due to is gravity is always downwards, right? Since the body is moving upwards, I take acceleration as minus g. Now, you need to calculate what is this height now here, right? You need to calculate what is the distance. You need to calculate what is the height. Okay, this height is nothing but distance traveled by the body. Yes, displacement of the body, and you need to calculate this one here. Okay, which formula shall I use? You know u, you know v, you know acceleration, and you need to calculate s. As you need to calculate s, I cannot use first kinematic equation v is equal to u plus at. I need to go with second. No, I cannot use because time is not known. S equal to ut plus half at square. Time is not known. So we shall move with the third kinematic equation, that is using v square is equal to u square plus 2as. Shall I use this? Right. What is the final velocity? That is 0. Shall I write 0 here? What is initial velocity? That is 20. 20 square plus 2. What is acceleration? Minus g, because it is moving upwards. When a body is moving upwards, take acceleration as minus g. Right? Okay. What is this height distance? You need to calculate. That s is equal to, it is nothing but what now here? Height above the building now here. Do you understand? This height is nothing but this height is above the building. This height I'm speaking now here, right? Okay. Now let me calculate this. What do you get? 0 is equal to 400. Let me take now here plus 2 minus 10. Okay. As 10 is given, let me substitute. Otherwise, I could have taken 9.8 now here, right? Okay. Into what do you get now here? H. So what do you get? 400 minus 20h, right? Okay. Let me bring a 20 this side. 20h is equal to 400. What is h is equal to? 400 divided by 20. So you will be getting with 20. 20 what now here? Meters, because height, it is in meter. So what is the height of the ball reached above the building? It is 20 meters. But you need to calculate what is the height of the ball. Height of the ball from the ground. From ground. Whenever we calculate height, we calculate from the ground here, right? So above it is 20. Then what is the height of the building? 25. You need to add both here, right? What is the height of the ball from ground? That is 25 meter. That is the height of the building plus this height. How much is the height now here? 20 meters. So how much do you get now here? 45 meters. So this is the answer, right? What is the height of the ball? Asked. Remember, height always calculated from the ground, right? This height we calculated 20 meter. The height of the building is 25 meter. So we got with 45 meter. So what is the total distance now here? That is 45 meters. Do remember this. So this is the height of the ball reached from the ground. That is 45 meter, right? Okay. Now this we calculated. Let me go with the second one. So what is second one? Let us check it out. The second is, how long will the ball take to reach the ground? What is time taken by the ball to reach the ground? Okay, let us take that. Right. Let us calculate what is the time taken by the ball to reach the ground. Time taken to reach the ground. Let us calculate it. Okay. Time taken to reach the ground. To reach the ground. Let us calculate this. Means this is the second one, right? This is the second one. Time taken to reach the ground. Let us check it out. Right. Okay. First of all, let us take how much time does it take to go up. Then let me take how much time does it take to come down. Let me add both here. Let me take that. Okay. Now let me consider this is a ball. See here. This is a building. So let me take now here. This is a building now here. Building, and if I am considering this is a building, let me take two cases. First case, there is a ball here. It goes up and again it comes down like this. What is the height now here? 25 meters. Right? Okay. Let me take what is the time taken to reach at the top, and then let me calculate what is the time taken to reach down. Let me take, there are two motions here, upwards and downwards. Let me calculate first upwards. Come on, tell me, what is the initial velocity? U is equal to, how much it is? 20 meter per second, right? What is the final velocity at this point? What is the velocity at this point? We know final velocity is 0. What is the acceleration then? Acceleration is minus g. Why minus g? Because the body is moving upwards. Whenever body is moving upwards, take acceleration as minus g. Right? So we need to calculate time. Okay, let me take two cases here. One upward motion. Let me take one upward motion, and next let me take now here downward motion. Shall I take upward motion here? Let me calculate t. I need to calculate t, right? We have u, v, a, and we know t. So which formula shall I use? V is equal to u plus et. Shall I use this, right? Okay, then what is v man? V is 0. Shall I take like 0? What is u? It is 20, right? Plus acceleration, that is minus g. What is time? That we need to calculate, right? What do I get? 0 is equal to 20 plus this is minus 10 t, right? G is equal to 10. So this, let me take this side. So 10 t is equal to 20. T is equal to 20 by 10. So how much do you get here? 2 seconds. This is how we calculated. Time taken by the ball to reach the top. How much second did it take now here? 2 seconds. Means we are calculating what is the time taken by the ball to reach up now here. Now let us calculate what is the time taken to reach the ground. Right? Simple. If I calculate that, then that will be the time taken to come downwards. Afterwards, let me add both. That will be the time taken by the ball to reach the grounds. Right? Okay. Downward journey. Let us check it out. What happens? What changes we can see in downward journey? Okay, now let us take downward journey. What is the initial velocity now? It is 0, because at the top we are considering, right? What is the initial velocity? 0. What is the final velocity? We don't know. So I cannot write that now here, right? Then, yes, another thing what you know? Acceleration. What is acceleration? Plus g. Why plus g? Because now the body is moving downwards. Whenever the body is moving downwards, take acceleration as g. And what are the other things we know? Yes, we know. What is the distance throughout this? We have calculated it. What is the height of the ball from the ground? How much is now here? 45 meter. Means, shall I say, this height is nothing but displacement. How much is the displacement? That is 45 meters now here, right? It is 45 meters. Now, what you need to calculate? Time. Shall I calculate this? Yes, you can calculate. By using which formula? S equal to ut plus half it square, because time is there in that now here, right? As we know, yes, shall I use S equal to ut plus half et square. What is initial velocity? It is 0. Shall I write it as 0 now here, right? Okay. Plus half. What is A? A is nothing but acceleration to the ground, because it is falling downwards now here, right? Then what is the t square? That we need to calculate, right? Okay. Now what is this displacement? Yes, we have displacement. How much displacement? 45, right? Okay, let us calculate this. 45 is equal to 1 by 2. G is what now here? 10. So what do you get now here? T square. 45 is equal to, this is 5 t square, right? Okay. Then 5 t square. Then what do you get now here? Let us check it out. Now let us calculate what is the time taken by the ball to come downwards now here, right? Okay. Now let us check it out like this. Then what happens now here? 5 t square is equal to 45 you got. T square is equal to 45 by 5. T square is equal to 9. Then what is the t is equal to? That is 3 seconds. Right? Time taken by the ball to reach the ground is how much now here? 3 seconds. How much time did it take to reach at the top? 2 seconds. What is the time taken to reach the ground? 3 seconds. Then what is the total time taken? Total time taken to reach the ground. Total time taken to reach the ground. So what is the total time taken? 2 seconds to go upwards, 3 seconds to come downwards. So what is the time taken here? 5 seconds, right? If I throw the ball with that velocity, it takes 5 seconds to reach the ground. This is how we calculated. Do remember, right? The last problem was a vertical motion problem, right? Do you remember? When a body falls downwards, take acceleration as g. If the body is moving upwards, take acceleration as minus j, because velocity decreases when the body is moving upwards. And when the body is coming downwards, velocity increases. And the important thing is that at the top of the vertical motion, velocity is 0. So these all things you need to consider while solving the problem. So these are some typical problems from the chapter motion in a straight line. Thank you.